a basic unit of measurement we use every day without questioning it. Familiar, ordinary, and taken for granted. Yet the meter is not what most people think it is. Because a meter is not a physical object locked away in a vault or preserved behind glass. It is not something you can point to and say, this is the original. A meter is a definition, a mathematical idea created by agreement. Defined by taking the distance light travels in 1 second and dividing it into an exact number of parts. And that number of parts is what we call a meter, which sounds precise and scientific, almost as if nature itself selected it. But that raises an obvious question. Why that number? Why not fewer divisions or more? Since the meter is the foundation of the metric system and deeply embedded in modern physics, you would expect the universe itself to explain why a meter is a meter. But it does not, because the real explanation does not come from natural law or fundamental physics. It comes from history, and history is far messier than science, filled with ambition, discovery, political chaos, deception, compromise, and more than a few people losing their heads. In 1789, France was boiling over. The people were furious with the monarchy. Inequality had pushed the nation to its limit. And King Louis was about to face a long list of grievances, one of which was surprisingly practical: fixing France's broken system of weights and measures, because it was a disaster. Every town measured things differently. Every trade used its own standards. Nothing matched, trade was slow, and cheating was easy. A problem that was not new. Since the Egyptian cubit was based on a man's arm and the English inch on grains of barley, raising the same question. Whose arm and whose barley? And in France, the situation had reached absurd levels, where a pound of bread could weigh less than a pound of lead. With nearly 250,000 different measurements in use, making trust nearly impossible, so a pint of beer in Paris could be 2/3 the size of a pint in nearby St. Denis, and if that was not an injustice worthy of revolution, nothing was. The revolutionary spirit demanded equality, equal laws, equal rights, and equal measures. But the scientists of the Enlightenment wanted more than fairness. They wanted a universal system, one that would work for all nations, not owned by kings or traditions, but derived from nature itself. So they proposed a new base unit called the meter, from which all other units would be derived, divided decimally, and labeled with Greek and Latin prefixes to give the system an air of permanence and authority, leaving only one problem: actually defining the meter. One early idea used a pendulum swinging once per second, an elegant solution supported even by Thomas Jefferson in hopes that America would adopt the system. But the plan failed because no one could agree on the length of a second, with some proposing to redesign the day itself into a decimal format. So the pendulum idea was abandoned, replaced by a new definition: 1/10,000,000th of the distance from the North Pole to the equator along a meridian passing through France, a choice that England and the United States rejected outright, ensuring the world would remain divided. In Et. 2 men, McCain and Delambre, were tasked with making the meter real by measuring the Earth itself. A simple idea in theory, measuring latitude at 2 points and connecting the distance mathematically, but impossible to do directly without a 1,000-kilometer tape measure. So instead, they constructed a chain of triangles across France, measuring angles with extraordinary precision using an instrument called the repeating circle, rotating it again and again to average out errors, producing the most accurate surveying measurements ever attempted, all in the hope of creating a perfect, error-free meter. But history intervened once more as the revolution turned violent. The king was imprisoned and executed. France went to war. Suspicion spread, and in city after city the scientists were nearly killed as suspected spies. After 7 years of danger and delay, the measurements were finally completed, calculations reviewed. And in 1799, a platinum bar was created, representing 1/10,000,000th of the distance from pole to equator, celebrated as humanity's first universal measurement derived from nature. Except it was wrong, because calculating the meter required knowing Earth's true curvature. And although scientists already knew Earth was an ellipse rather than a perfect sphere, the expedition's results suggested it was far more flattened than it really is. Due to a poor choice of measurement path and the fact that Earth's curvature is uneven and irregular, making it unsuitable as its own measuring stick, which undermined the entire premise of the meter. But admitting failure would have meant losing 7 years of work and countless lives risked. So new data was combined with older measurements, smoothing over errors, turning the meter into an estimate and a physical object. Exactly what it was, never meant to be. With the added complication that one of the scientists even altered some of his data, a scandal revealed only later. Today, we no longer define the meter using a metal bar, at least officially. Yet in 1960, when it was redefined using atomic wavelengths, the values were chosen to match that original platinum bar. And again in 1983, when it was redefined as the distance light travels in 1/299th, 792,458 of a second. The number was selected to preserve the same length, meaning the original error lives on. Because modern satellite measurements show that 10 million meters from pole to equator would still fall short by about 2 kilometers, leaving today's meter 0.2 of a millimeter shorter than it should be. Yet it remains a meter simply because we say it is, since no law of the universe demands one. It does not emerge naturally from physics. It is an invention. But as inventions go, it reshaped science, trade, and civilization itself. And that made it truly revolutionary. So stay curious.